Hello, everyone. Hope you're all doing well, having a great time, and of course, staying safe. This is science lesson, class 4, unit 6, and lesson 3. So, in this lesson, we will try to talk about magnets, how they work, and what are the magnets. So, let's start. So before we talk about today's lesson, let's do the review in page 245. And we will start with the first question. The first question says, what is an electric current? An electric current is the flow of electric charge. The second question says, describe what has to be in place for a circuit to work. So for a circuit to work, you need conductors and insulators, bulb, wires, and batteries, or a battery. Next question says, contrast conductor and insulators. A conductor allow electrical energy to pass through them, whereas insulator do not allow electrical energy to pass through them. Moving on to the critical thinking. Most of the outlets in your home have place for two plugs. Infer how you can connect several lamps to be lit from the same outlet. How do you know? Now, to answer this, you should know which kind of circuit we use in our homes. I've told you in the previous lesson, most standard type of circuit in our homes are parallel circuit. So in parallel circuit, whenever you turn off one of the bulb, it doesn't affect the other ones. Moving on to the last question, it says, what supplies energy in an electric circuit? So your answer should be B, electric cells. Let's talk about today's lesson, which is magnet. So what is a magnet? Magnet is an object that attracts certain material, usually objects made of iron or steel. So as you can see in front of you, a magnet has two poles, or you can say a magnet has two ends. One of these ends are called south, the other one is called north. A magnet's pole is strongest at the poles. If a bar of magnet can swing freely, one end called the North Pole will always point north. The opposite end, called the South Pole, will always point south. A magnet's North Pole is usually marked as N, capital N, and of course, its South Pole is marked as S or capital S. Another thing you should know about magnet is that no matter how many times you cut a magnet, each piece will be a magnet with a pole at each end. Look at the magnet in front of you carefully. So at first, we have a big bar of magnet. Then we cut it in half. We see a magnet has become two bars of magnet. Each one of them has its own north pole and its own south pole. Let's talk about magnetic force. If you have ever played with two bars of magnets, you have probably felt them pull toward each other. At other times seems to be pushing away from each other or repel each other. So these force you felt are a magnetic force caused by magnetic field. So what is a magnetic field? Magnetic field is the space all around a magnet where the force of the magnet can act. You can see these fields in the picture in front of you if you look carefully. However, a magnet can move iron fillings into a line. The pattern in those pictures show you the magnetic fields or the shape of the magnetic field. The force between magnets poles are just like the force between electric charge. Opposite magnetic poles attract and like poles repel each other. So imagine if you held a north pole of a magnetic bar near the south pole of another magnetic bar, these two bars will attract each other, while the north pole and the north pole of two different magnetic bars will repel one another. You can look at the picture in front of you. You can see different poles of two different bars of magnets near each other. So what happens in this case is that their fields form a close pattern. This close pattern of line shows the force that pulls the magnets together. Now look at the upper picture where the north and the other north are near each other. The magnetic fields form an open pattern of lines. Just as the electrical charge, this pattern shows the force that pushes the magnets away from each other. Let's talk about how current make magnets. So you can make your own magnets, or you can turn a needle into a magnet. How? By rubbing the needle over the magnet many times and always in the same direction. This makes the needle itself a magnet. You can try this at home. I want you to try it to see it for yourself. Now, another way to obtain a magnet is by allowing electric current to pass through a conducting wire. You may verify this by connecting two ends of a conducting wire to a terminal of a battery. You also need a small compass. Then we will see what will happen. So whenever the current flows through the wire, place the small compass to the current carrying wire. Now what you will see is that the needle is pointing in a new direction. So then the needle of the compass will start moving and it will point into a new direction. You also need to know that this field is usually weaker than the field of a bar of magnet. But also you can obtain a stronger field by adding coils to the wire. The strength of the field increase with the increase in the numbers of a coil. So more coils you add, stronger field you get. Also, you can increase the strength of the field significantly by introducing an iron rod inside the coil. The wire around the rod is called electromagnet, and this only works when electric current goes through it or pass through it. Also, the intensity of the current also affects the strength of the magnetic field. As the intensity of the current increases, the magnet gets stronger. Finally, the electromagnetics have many industrial applications. What does it mean? It is basically used in industry. Large electromagnets are used to lift heavy metal scraps and old cars to move them to other places. Also, they are used in designing bells for houses. So magnets are used in designing bells for houses. Let's talk about compasses. What is a compass? What you see in front of you is a compass. What is the use of a compass? For hundreds of years, people have used compasses to know their direction. The first magnet used were made of heavy natural material called lodestone, as you can see in front of you. So how does the compass work? A compass that you use today uses a light-weighted magnetic needle that is free to turn. This is much like the needle you made in the previous slide, if you made it, of course. Now the compass needle points along the imaginary line connecting the North and the South Pole. You already know that Earth is a gigantic magnet and it has a north and south. So the compass needle points along the imaginary line connecting the North and the South Pole. Now, you also need to know that the Earth's magnetic field is just like the field of a giant bar of magnet. How magnet poles affect a compass? A compass placed near a bar of magnet will point toward one of the magnet's pole. And if you change the compass to another side of the bar, the needle will move along the bar. Now, of course, you can try this at home too. It's a very fun experiment. Try it and send me your video or your picture if you like. We reached the end of this lesson, so your homework will be the chapter review in page 254 and 255. And thank you for your attention and have a great time. Good luck.